Okay, here we go, some pointers for homework sheet WW5. First question, find the gradient at the point 410. So it's asking for a gradient. It's not about straight lines, so that means we're going to have to differentiate. However, before we differentiate this function, first thing we need to do is get it in a form where we can actually differentiate it. So we need to turn the first root sign into x to the power. Now because there's a root there, we know it's a fraction. Square root means it's over 2, so 3's on the top, plus square root of x, we know that's power a half. Now we've got it in this form, now we can work out what the y by dx is. So bring down the 3 over 2, take away 1, plus, you can do the next bit, bring down the half, take away 1. Put the root signs back in, so 3 square root x over 2 plus whatever this one is, and then you've got to substitute into that formula x equals 4. So you're going to put the 4 in here for x, and you're going to put the 4 in the x over here and work out the answer. Question 2, we're told what sine A is equal to, and then we're asked to find the value of cos 2a add sine A. Now cos 2a can be expanded to cos squared a minus sine squared a. Second part is plus a. Now we know from the question up here that sine a is 2 over 3. So I can immediately put that 2 over 3 into the places where the sine is. So that can go in there, and it can also go in there. However, I've got an issue, what am I going to put in for cos A? So the way we work that out is we go back to our right angle triangles. We know that sine A is 2 over 3. A little bit of Pythagoras is going to tell me what that side there is. Then I can write down what cos A is equal to. Once I've got that, I can substitute that in there. Okay, so you're going to have a fraction squared, take away a fraction squared, plus a fraction. They should all come out to be nice, easy numbers for you to work out the answer. Question 3, calculate the angle in 3 dimensions. So the formula we're going to use is cos theta equals u dot v over the length of u times the length of v. Now looking at the question, you might be thinking to yourself, why is he using u's and v's? The question doesn't even mention u's and v's anyplace. But the reason I'm using a u and a v is because this vector here is going to be vector u, and this vector here is going to be vector v. So u is the vector b to a, which is little a minus little b. So take your components, subtract them, and then that's going to be vector u. Vector v in exactly the same way is b to c, which is little c minus little b. So work out what that is. Then we need to take both of these vectors and we need to substitute them back in up here. Remember, the first part, the dot product u dot v, means the first vector here, the first component, here, times the first component here, second component times the second component, third component times the third component, and then you add them up. So that tells you the top, so you've got a nice wee number there. The length is when you do Pythagoras, so you take each of these components, we square them, so one number squared, plus another number squared, plus another number squared, and then square root. And it's these numbers that go in here. Check back your jotter, you'll find you've done a few of these. Question 4, 2 functions. We've got to work out what f of g of x is. So that means we need to put the g formula in here. Well, that's not particularly difficult, we just get 1 over the square root of 4 minus x. Okay, that's the easy part. The hard part is you have to write down the possible domain. Okay, now remember, domain is the numbers that go in. So in other words, looking at this part here, okay, this part, the bottom part, is there any numbers which you cannot put in there? Now, because we're dividing by a formula, then that formula is not allowed to be 0. If that formula is ever 0, then we've got 1 divided by 0, impossible. Also, because of the square root, this number here cannot be negative. So that means that 4 take away x, the bit inside my green bubble, must always be a positive number, must always be bigger than 0. So all you need to do is solve that equation, or an equation. Now remember, once you've got the answer, we need to use set notation, so x can be any number as long as whatever your answer is. Question 5. This is a very, very common question, guys. 3 consecutive terms, find a and b. So, from your recurrence relation, this part here, we know that u2 is a times u1 plus b, and we know that u1 is 20, and we know that u2 is 10. So that means 20 times a plus b equals 10. How did I get that? I just simply put 20 in for u1, so a times u1, and I put 10 in for u2 equals 10. Similarly, looking at the next one, u3 is going to be a u2 plus b. So we're going to put 10 in for u2, and we're going to put 7 in for u3. So that's going to give us an expression which says 10a plus b is equal to 7. And then I'm going to take this formula, I'm going to take this formula, and I'm going to do simultaneous equations with them. Once you've done that, part B is easy because we know the formula for the limit is b over 1 minus a. So whatever you get your a and b's to be, plug them into this formula. Question 6, find the stationary point. So yep, here we go, differentiate again. Differential of x is 1. Differential of root 2 sin x is root 2 cos x. Now remember, for your b statement, for stationary points, the y by dx has to equal 0. So you have to put this formula 1 plus root 2 cos x equal to 0. Okay, how do we do that? Well, we take the 1 over first of all, so we get root 2 cos x equals negative 1, and then we take the root 2 over to get cos x equals negative 1 over root 2. Now you should know what that is as an exact value. Once you've got that point, substitute it back in here to get the y coordinate. Question 7, we have a circle. Let's draw the circle. We know its centre. Well, we get the centre by looking at this number here, dividing it by 2 and changing the sign, and this number here, dividing it by 2 and changing the sign. So negative 12 divided by 2 with the sign changed as 6, negative 2 divided by 2 with the sign changed as 1. So we know the centre is 6, 1. We are told to find the tangent at the point 3, negative 3. So on your circle you've got a point here which is 3, negative 3. And then we are asked, what's the equation? Oh dear. Go away. What's the equation of that line there, that tangent? So how do we go about that? First thing we need to work out is the gradient of the radius. We know what that is, because we know what this point is, we know what this point is, so we can work out the gradient of the radius. Once we've got the gradient of the radius, we can work out the gradient of the tangent, because we know it's perpendicular. And then all we need to do after that is take my tangent gradient, take my point on the edge, and plug both of these into y minus b equals mx minus a. And work that out. Question 8. Prove that the points are collinear. So, we're going to work out k to l first of all, which you know is little l minus little m. So just get your vectors, do a takeaway. Then we're going to work out L to M, which is little m minus little l. So the same thing repeated. Now we're trying to find some sort of connection between this vector here and this vector here. Now if you've done it properly, guys, it should be quite obvious what that connection is. 1 is twice as big, 3 times as big, 4 times as big, something like that. After you've got that, you need to write down your statement that K, L and M are collinear because, now there's two conditions, remember. First one is that they're parallel, so you need to mention that, and the second one is there's a common point. And then the last part of the question, what's the ratio? The ratio should come from the connection you found here. Question 9, believe it or not, I think this is the easiest question on the sheet. Okay, it's certainly the quickest one. So if I've got to solve this, problem is I need to get rid of that log to the base 2. Okay, so I'm left with p squared minus 4 equals. Now how do you get rid of a log? The opposite to logging is powering. And there is a 2, so it's 2 to the power 5. So all I'm asking you to do is work out that equation now. Okay, what is 2 to the power 5? Take the negative 4 across, square root, get your p. Lastly, number 10, probably the one that's going to have the most algebra in it. Looking at your quadratic that you've got there, then the value for a is the number before x squared, the value for b is the number before x, and the value of c is everything else that's left. Now would you please note that I've taken the 5 over, right? So the value for c is k minus 5. Now what's the condition for real distinct roots? B squared minus 4ac has to be bigger than 0. So all you have to do now then is put 6 in here, put 4 in here, put k plus 3 in here next to the 4, and put k take away 5 in here. Okay, so you've got 6 squared minus 4 times k add 3 times k take away 5 is bigger than 0. Okay, how am I going to solve that? I'm going to remove all those brackets. I'm going to take it away from 36. Things should cancel out. You should get a common factor, and then you can solve it to get your k answers. Okay, quite quick this week in my instructions, but you should be able to do some of these yourself, I hope.